rational expressions, and I've taken this and I've rewritten it as a long division problem from elementary school. So the divisor is x plus 4, the dividend is the polynomial inside, and then my answer, the quotient, will go on top. If I have a remainder, my answer would be the quotient plus the remainder over in this problem, that would be x plus 4. So let's go through the process of figuring out how to do long division on the polynomials. So the first thing to do is compare the x in the binomial factor to x squared on the inside. I would need to multiply this x by another x in order to get x squared. So the first term in my quotient is x, and I line my powers up in a column so that all the powers in the problem are lined up nice. So then I start a process of trying to eliminate the x squared term. X times x is x squared. X times 4 is positive 4x. And I have to add the opposite of each term, or subtract this sum from x squared minus x. The whole point is to eliminate x squared. So x squared minus x squared is 0. X minus positive 4x is negative 3x. And then negative 8 comes down. And the process starts over again. I'm comparing the x in the x plus 4. I'm comparing the x from the binomial factor with negative 3x now. So x would need to be multiplied by negative 3. So the missing factor is negative 3. And then the process starts over again. Negative 3 times x is negative 3x, and negative 3 times positive 4 is negative 12. And I'm taking the opposite of this sum. The whole point here is to eliminate 3x. So negative 3x minus negative 3x sums to 0. Negative 8 minus negative 12 is 4. 4 is my remainder. Since I'm out of dividend terms, there's nothing left up here to bring down. So 4 is the remainder. The way you would present your final answer to this problem, the quotient is x minus 3 plus the remainder over the divisor, which is x plus 4. And the answer looks like a mixed expression from an earlier section of chapter 6. The next problem is number 19 on the back of your sheet, and I've written it. It's presented as a rational expression, but I'm going to go ahead and present this in the format of long division. So I start with the x in the binomial factor, comparing it to x squared in the dividend. Once again, I would need to multiply by a term of x. So x times x is x squared, and x times negative 1 is negative x. And I'm taking the opposite, I'm subtracting the two, taking the opposite. X squared minus x squared is 0. Negative 7 minus negative x leaves you with negative 6x, and then negative 8 slips down. And then the process starts over again. You're now comparing the x to negative 6x. So the missing factor would be negative 6, and then you start the process again. Negative 6 times x is negative 6x, and negative 6 times negative 1 is positive 6. And once again, I'm taking the opposite. I'm subtracting these in a vertical column form. So negative 6 minus negative 6 sums to 0. Negative 8 minus 6 is negative 14. And you look at the dividend and you see there are no terms left, so negative 14 becomes your remainder. The way you present your answer, the quotient is x minus 6 minus 14 over the divisor of x minus 1. This is number 14 on your notes, printed out for you. So once again, it was presented as a rational expression, and I'm on the video, I'm just going to go ahead and turn it into a long division problem. So starting with 2x, comparing it to 2x squared, the missing factor would be x, so I'm placing it in the column with all of the x to the first powers, and then the process starts. X times 2x is 2x squared, x times positive 1 is x. And I'm taking the opposite of this sum. 2x squared minus itself is 0, which is what I wanted to happen. Negative 5x minus x is negative 6x. And then negative 10 slips down. And now I'm comparing 2x to negative 6x. The missing factor is negative 3. So the next term in my quotient is negative 3. And then the process starts again. Negative 3 times positive 2x is negative 6x, and negative 3 times positive 1 is negative 3. And I'm taking the opposite of this because the whole goal in this step is to eliminate 6x. And I have successfully done that, and I have negative 10 minus negative 3, leaving me with negative 7. There are no terms left in my dividend, so negative 7 is my remainder. The way I present my final answer, the quotient is x minus 3 minus 7 divided by 2x plus 1, once again as a mixed expression.